Okay, we're now ready to complete page 10 in our interactive notebook. So just make sure that you fold it so that you can still see the title of this section, 1-6, Describing Angle Pairs. So you have two new vocabulary words for this section. The first one is a linear pair. Linear pairs are adjacent and supplementary angles. So you can see in this diagram that angle 1 and 2 are adjacent angles because they share a common side. And they are also supplementary because they're going to add up to 180 degrees. So those are your properties of a linear pair that you're going to need to know. So again, linear pairs, they're adjacent and supplementary. Down at the bottom, you have vertical angles. So vertical angles are formed when you have two intersecting lines. So it says right here, two angles are vertical angles when their sides form two pairs of opposite rays. So again, you're looking at these intersecting lines and you'll see that there are four angles that are created. So angle 3 and angle 6 would be vertical angles because their sides are opposite rays, as well as angles 4 and 5. And then an important property of vertical angles is that vertical angles are congruent. So angle 4 and 5, they're congruent. And 3 and 6 are also congruent. And remember, congruent means that they're going to have equal measures. So if angle 4 is 150 degrees, then angle 5 is 150 degrees. If angle 3 is 30 degrees, then angle 6 is 30 degrees. So again, take a look at the angles that are formed by intersecting lines. You can identify the angles that are vertical and understand that those angles are congruent. So vertical angles are congruent, and then you have linear pair, which is adjacent angles that are also supplementary. All right, so let's take a look at a couple of examples for today. So here's our first diagram. We need to find the value of x and y, then find the measure of each angle in the diagram. So looking at this diagram, you can identify a linear pair. So just covering up part of this diagram, you'll see two angles, this x squared minus 2x and negative 6x. Those angles are a linear pair. They're adjacent because they share a common side, and they're supplementary because they're going to add up to 180 degrees. So I could set up an equation where I add up these two angles and set it equal to 180 degrees. So you'll have x squared minus 2x minus 6x equals 180 degrees. That's using your definition of a linear pair, because linear pairs are supplementary. And then you could go ahead and solve this equation for x. Please understand that this is a quadratic equation, so you are going to have to put it into standard form first. So combine your like terms, that'll give you negative 8x. Subtract 180 from both sides, so you'll have x squared minus 8x minus 180 equals 0. And just like any quadratic equation, you could either factor this or put it into the quadratic formula. I'm going to go ahead and factor this because I know that negative 18 and positive 10 multiply to give you negative 180 and add to give you negative 8. So positive 10 and negative 18. If you set both of these equal to 0, you'll get x equals negative 10 and x equals 18. But just like in the previous section, you want to make sure that when you substitute those values of x back in, that you're getting positive angle measures. So notice if you were to plug in 18 in for x, you'll get negative 6 times 18, which is going to give you a negative value. So if you do negative 6 times 18, you're going to get negative 108, but you're not going to get an angle that's negative 108 degrees, so that value is not possible. So then you have to check for negative 10. So if you were to plug negative 10 in, negative 6 times negative 10 is positive 60. So I'm going to put that in. This angle here we know now is 60 degrees. And then I'm going to do the same thing here. I'm going to do negative 10 squared minus 2 times negative 10. So negative 10 squared is 100. 2 times negative 10 is negative 20. And then remember the minus and negative you can change to plus a positive because we don't like those double negatives. So that angle is 120 degrees. So I'll put that right there in the diagram as well. All right, next I have to find the value of y. So taking a look, I actually have not just linear pairs in this diagram, but I also have vertical angles. So take a look at these intersecting lines that I'm highlighting for you. You'll have a pair of vertical angles that are being formed. So remember what we said on the previous page. If this angle is 60 degrees, the angle that's vertical to it is also 60 degrees. So I can go ahead and write that in there because I know that they're vertical and vertical angles are congruent. I know that this symbol means that those are perpendicular, and perpendicular means that they intersect to form a right angle, which is 90 degrees. So now I can figure out the measure of this angle by either looking at this whole diagram as one big circle, which is 360 degrees, and I could subtract 90, 60, 120, and 60 from 360. So again, I could treat this as one big circle and subtract all of the known values from 360, and that will give me the missing piece. I could also, again, cover up half of the diagram and realize that those three angles form a straight line, and a straight line is 180. So I could subtract 60 and 90 from 180, and that will also give me that missing piece. Either way you approach this, you're going to get that that missing angle is 30 degrees. So this missing angle is 30 degrees. So to solve for y, you would do 2y plus 10 equals 30. Solve for y will equal 10. So in this particular example, y is equal to 10 and x is equal to negative 10. And I found all of the angle measures that are in this diagram. The second example that we're going to do, you're going to have to use your definition of vertical angles and linear pair to set up a system of equations. So taking a look at this, I can identify my vertical angles, just like I did in the previous example. Because again, you're going to have those intersecting lines. And just remember that vertical angles are congruent. So these are going to be equal. So 2x plus y has to equal 140 degrees. The other equation, again, you can cover up part of this, is taking a look at the linear pair that is formed. So 2x plus y and x minus 2y form a linear pair. And remember, linear pairs add up to 180 degrees. So you can add those up and set it equal to 180 degrees. So the 2x plus y, the x minus 2y form a linear pair, so they add up to 180. So this is my system. Okay, so if you can remember back to when we reviewed solving systems, you could either solving it using graphing, elimination, or substitution. Before I choose a method though, I'm going to simplify this bottom equation because I can combine like terms. So I'm not going to do anything to the top equation. I'm going to leave that alone. But the bottom equation, I have 2x plus 1x, which is 3x. And I have 1y minus 2y, which is just minus 1y. And then that still equals 180 degrees. So simplifying that second equation in this system allows me to use the elimination method right off the bat. Because if I were to go add these two equations, the 1y and the minus 1y would cancel, and I could just solve for x. So I'm going to go ahead and do that. Again, the y's will automatically cancel. 2x plus 3x is 5x. 140 plus 180 is 320. Divide both sides by 5. And 320 divided by 5 is 64. So I automatically have that x is 64 using the elimination method. And now I have to go back in and get y. So I'm going to stick with the top equation. So I'm just going to write 2x plus y equals 140 because I already know that because they're vertical angles. And I'm going to substitute 64 in for x and solve the equation for y. So 2 times 64 is 128. And then subtract 128 from both sides. And 140 minus 128 is 12. So I have x is 64, y is 12, and now I want to see, does that match up in my diagram? So going back into the diagram, if you plug in 64 for x and 12 for y, 2 times 64 is 128, and 128 plus 12 is 140. So this angle is 140, just like it's supposed to be, because it's vertical to the 140 degree angle that we're already given. The other angle, x minus 2y, again, substitute 64 in for x and 12 in for y. So 64 minus 2 times 12. 2 times 12 is 24, and 64 minus 24 is 40. So this angle is 40 degrees, which is perfect, because 140 degrees plus 40 degrees is 180, which is what we wanted since they're a linear pair. The other missing angle is vertical to the 40 degree angle that we just found. So we can go ahead and label that 40 degrees as well. So you'll see that vertical angles are equal, the 40 and the 40, the 140 and the 140. And you'll also notice that the linear pairs add up to 180, because you'll always have a 140 and a 40 as you match up your linear pairs.